40. Okay, so your opener says the 12th on it, but it's actually April 23rd. So we're playing a little catch up here, and it's just a kind of a good review for us to start with. So the first part of the directions say, find the greatest common factor in each of the following groups. We're going to show all our work and label and box our answer. So again, it's not the 12th. It's actually 423. So when we're finding the greatest common factor, what am I going to have to do with these two terms or these two numbers? By starting and making a... Okay. So what are two factors of 48? How about try that again for 48? 8 and 6. That sounds much better. Okay. And then for 6, and I'm going to circle those because they're prime. And then for 8. Okay. So now I come to 60. What are two terms that I can, or what are two factors that I can multiply together to get 60? 6 and 10? Do you have to use 6 and 10? Nah. Okay, and then for 6, did you get 410 as well? I gave Callie that one too. Okay, 6, we already know it's 2 and 3. And then what's my factors for 10? 2 and 5. Okay? After I factor them, I come down and I write each term. And what do I write next to each of these terms?
The numbers.
What numbers?
2 plus 2 plus 3. Wait, they gonna have 3 2s. Wait, 4?
You have 4 2s and 1 3.
Okay, so what are those numbers called? Those are your prime factors. And we're going to put them in order from least to greatest. So we had 2 times 2 times 2 times 2 times 3, right? 1, 2, 3, 4, 5. And then for my next one, I'm going to have 2 times 2 times 3 times 5. Now what do I do? Well, we don't want to say pairs anymore. We want to circle what they have in common. So what do they have in common?
2.
They have 3 in common.
Okay. So then I drop down. I put the greatest common factor equals. So what do I put down now? 2 times 2 times 3. So 2 times 2 times 3 equals 12. So the greatest common factor for these two terms was 12. So that one's just starting off pretty basic, right? This next one is going to get a little more complicated. Because not only do we have numbers to worry about, but we also have, what's with our numbers there? Variables. So we're going to ignore those variables till the end, and we're going to go ahead and factor all of our numbers. So David, what two numbers can I multiply together to get 30?
10 and 3. All right, for 10, it's going to be 5 and 2.
Okay, Cody, for 75?
25 times 3. 5 and 5.
And Kaylon for 45.
What is it? 5 and 9. 3 and 3.
Okay. So then I come down and I make my groups. So I have 30. I have 75. And then I have 45. Okay, what are my prime numbers in order from least to greatest for 30?
2 times 3 times 5.
For 75?
3 times 5 times 5.
And for 45.
3 times 3.
Okay? What's my next step?
See what they have in common?
Yeah, see what they have in common. What do they have in common?
3.
With 3. I'm going to have some sloppy coloring. And they have a group of 5s. Doesn't matter which 5 I circle. Do I have to circle these, or can I just circle these? Does it matter? Nah. Do they have anything else in common? No. Okay, so then my greatest common factor is going to be 3 times 5, because I bring those two numbers down. What's 3 times 5 equal? 15. Now here's the fun part. This is the part I like. We come back and we look at our variables. Do they all have an x? Yes. So we're going to pick the x with what? The greatest exponent or the smallest exponent? Smallest. So what's the x with the smallest exponent? So x squared. Then we go to our next variable. Do they all have a y? Okay, what's the one with the smallest exponent? Y squared. That's all right. And then, do they all have any other variable in common? No, because only 2 of them have a y. The 30 doesn't, or excuse me, only 2 of them have the variable z. The 30 doesn't, so they all 3 wouldn't have that in common. So my greatest common factor here is 15x squared, y squared. This greatest common factor here is going to play in a role on the back side of our opener. The back side of our opener is what we're going to learn today. Okay? So if you notice, Mackenzie has her opener flipped over right now, and it says, factor the following polynomial using your greatest common factor you found on the front. Well, on the front, did we find the greatest common factor for 75y4, y squared z6, 45x to the 5th, y to the 4th, z, and then 30x squared y to the 3rd? Yes, we did. So when you flip your opener over, up at the very top of it, so at the very tip-top part, write GCF and write what the greatest common factor is. Don't write it next to your equal sign. Write it at the very tip-top part, because we're going to use that number, okay? Because once I flip off of this page, that number for me is gone. So right up here, write GCF, and then write what the greatest common factor was. Did you lose your pencil?
Yeah.
Have you had a pencil this whole time?
No.
David Eugene Cozart. I don't know if that's his middle name. That's my go-to middle name. Do you have your phone, David? Take a picture of the open or the front side. Oh, it was your phone that was plugged in there. Is that why you're so quiet? Good thing I didn't. Okay, get a good picture of it so you can write it down. That's just my go-to middle name. Is it not coming up?
It is.
Okay. Hurry up. Is it not working?
It is.
Here, I'll pause. All right. So, the back side. We're going to use the greatest common factor that we found on the front side, which was 15x. Okay. Now, when we are given an area model, we know we're going to fill it out. What do these 3 terms represent for our area model? Before you answer that, what have we been working with? What was our very first lesson of the triad? It was finding the what? Kelly? Yeah, the area of a rectangle. So area of a rectangle equals height times width, right? So when we have the 3 terms like this that don't have parentheses, what do these numbers represent? When the parentheses are not present, what do those numbers represent?
Sorry. This person.
She's home, man.
Okay, thank you.
Mm-hmm.
Wait.
Try it again. These 3 numbers here, what do they represent?
The height and width?
No. Are there parentheses? Yes. If there's not any parentheses around them, then that means they're the area. If there are parentheses around them, that would represent our height and our width. So this 75x4 y squared z to the 6 is the area of my first rectangle. So we're going to put that down there. So it's going to be 15x 4 y to the second z to the 6th. That's my first area. What's the area of this second rectangle? What's the area of this rectangle? 45. X to the 5th. Y to the 4th. Z. And remember, we always put our area at the bottom of our area model. And what's the area of my final rectangle? What's the area of that final rectangle? What kind of 30? So negative 30. You guys are a hot mess today. X squared, y to the 3rd. Okay. Now, last week, we worked on filling it out backwards. We were given a little bit more information than this, right? Because we were given the height last week. Well, this week, I'm not giving you the height, am I?
Nope.
So what we're going to have to do is find the greatest common factor of these three terms, which we already did, right? The greatest common factor of these three terms is 15x squared y squared. The greatest common factor of your terms becomes your, what do you think? Is it going to become your height or your width on your area model? You're given one number.
Height.
It's going to become your height. So your greatest common factor becomes the height of your area model. So we're going to put that on the outside for our height. 15x squared y squared. So what do we know about our area model now? What do we know? We know the height and we know the area. So what do we need to find? The width. So this is pretty much here is what we learned last week. So the new part is finding the greatest common factor and making that your height. So let's find our width now. So when we go to find our width, I go ahead and put my height in each area or each model. Oh, guys, what am I doing?
What are you doing?
I don't know.
4? I thought it would be 2.
Yeah, it is. Now I'm a hot mess. I'm joining you all. So I'm going to put this in each of my boxes so I actually write down the right number. So I have my height, and you guys told me I'm going to find my width. So here we go. Let's find the width of each rectangle. So when I go to find my width, I work with my numbers first. 15 times what will get me to 15? 15 times 1 will get me to 15. Then I look at my variables. I have x squared. I have x to the 4th down here. So if I have 2 x's up here and I end up with 4, how many more do I need?
2.
So it's going to be x squared. Then I go to my y. I have 2 y's here and I have 2 y's down here. Do I need any more y's? I don't have any z's up here, but I have 6 down here. So how many z's do I need? So z to the 6th. Because this represents my width, I also need to bring it up above. So 1x squared z to the 6th. What can I get rid of in this width? What do I not need to have? No, well, I didn't have to use the y because I already had it. I need the z, you guys.
The 1.
The 1, right? I don't have to have that 1 in front of the variable. If you choose to leave it there, that's fine. If you don't want to put the 1 in there, that's fine too. It's still the same answer. Okay, let's find the width of my second rectangle. So now I have to think 15 times what gets me to 45? 15 times what gets me to 45? Say it again. 3. Okay. Now I look at my variables. I have x squared, and I go x to the 5th. So if I go from 2 x's to 5, how many more do I need? So x to the 3rd. Now I look at my y's. Y squared to y to the 4th. So how many more y's do I need? Up here I don't have any z's. Down here I have 1. So what do I need? Just 1 z. So what's the width of this second rectangle?
3.
3x.
To the third, y to the second, z.
Okay. We have 2 more things to do and then we're done. Okay? So the second to last thing we need to do is find the width of this rectangle. So 15 times what will get me to negative 30? If you don't know how to... Negative 2. What if you didn't know that 15 times negative 2 will get me to negative 30? What's another trick that you could do? Anybody know? If you couldn't think 15 times negative 2 will get you to 30, you could just take negative 30 and divide it by 15, and it'll give you negative 2. Okay? Okay, so now let's look at our variables. X squared, X squared. So do I need any more?
No.
Now I have Y squared, Y to the third.
You need 1.
I need 1.
So it's going to be Y.
Do I need anything else?
No.
So what's the width? What's the width of this rectangle?
Negative 2y.
Okay, so remember, area, this is right here, equals, what's my area equal? Height times, okay, so what's my height? What's my height of this?
Now you got to add them all up.
15, x squared, y squared. So my height times, so how am I going to show times my width? What am I going to use? Parentheses. Okay? What's the width of my first rectangle?
1
X squared.
x squared z.
Okay? Then what do I put?
3.
No, plus.
Plus, because it's a positive, then 3. So my next width. Then what do I put?
Negative
Negative.
2y.
And 2 more things I need.
Parentheses.
The end parentheses and box. This is what we're doing today. So last week we found how to find the width. So last week we learned how to find the width when we were given the height and the total area. So this week the new thing that you're learning is finding the greatest common factor to find the height, then filling out the rest of the area model.